All right, so both the TI calculator, the graphing calculator, and Desmos will do the sigma notation for you. If you're working with a graphing calculator, go into your math menu, and it's about the 9th or 10th thing in the menu. It might have that sigma, I think it'll have the sigma um, Greek letter, or it might say summation, okay, depending on the age of your calculator. On Desmos, you just need to go to Functions and Miscellaneous, and right there it is, that little sigma guy. With the Desmos, you have to use n as your variable. With the calculator, you can just use x. Yeah, x is fine. So the one problem we did was from 1 to 4. And then make sure you put the formula in parentheses on both the calculator and on Desmos. So I think we did 4n plus 1. We used i's, and we got 44. So just so you know, that's available to you in both versions. That's kind of nice when you have longer problems to do. All right, so going back, your book has property of summation. So if you're adding where c is a constant, it's just n times c. If you have a constant here, you're allowed to pull that out of a summation and do the summation and then multiply by c. If you have adding or subtracting, you're allowed to pull them apart. We don't do a whole lot with these right now. In calculus, we're going to have all kinds of fun with these properties. All right, now a series is a sum of a sequence. So if we take a sequence and add up all the terms, that's called a series. A finite sequence, if you have a sequence that ends, that has what's called an nth partial sum. And it might look like this. Okay, what we just found was a partial sum because it starts at 0, it goes to 4, it ends, we can add this up. We can also add infinite series. So we start at 1 and we go to infinity, and that just means we keep plugging in and it keeps going on and on forever. Okay, so we're going to take a look at a couple of these. First, number 9, we want to find the fourth partial sum, and then we want to find the infinite sum. We can't always find the infinite sums. We can on this one. I'll show you. It's great. You'll love it. All right, so the fourth partial sum means what we're doing is we are starting at 1 like they asked, but instead of going to infinity, we are only going to 4. Okay. So to find the first term, it's 5 over 10 to the first, and then 5 over 10 to the second, and 5 over 10 cubed, and 5 over 10 to the fourth. Now, let me show you what that is. I want to write that in a different way. This is 5/10. Let me write that as a decimal, 5/10. This is 5/100. This is 5/1000. And this is 5/10,000, whatever. And when you add that all up, you get 0.5555. Now, part B is saying, well, what if we keep going? Well, we have 5/10, 5/100, 5/1000, 5/10,000. Next one's going to be 5/100,000, and then 5/1,000,000. So this is 0.5 repeating, which turns out to be 5/9. Okay. So for this one, we can find the infinite sum of this thing. I should probably write it. And it is 5/9, which is kind of cool. All right, I think we got one more problem to do today. An investor deposits $1,000 in an account that earns 3% interest compounded monthly. So the balance after n months is given by this formula. That should look familiar to you. We've used that formula before. We want to write the first 3 terms of the sequence. All right, so to find the first term, we're doing 1,000, 1 plus 0.03 divided by 12 to the first. So after 1 month, we have, I'm going to need a calculator for this, definitely, $1,002.50. For our second term, we're going to plug in 2, and we get $1,005.01. And the third month, again, just plug it into your calculator, and we get $1,007.52. Okay. And then we want to find the balance in the account after 4 years by computing the 48th term of the sequence. Okay. So we're just finding the 48th term, because remember this is monthly, so that's after 4 years. And our friendly calculator says $1,127.33. Okay. In the next lessons, the next 2 lessons, we'll get more specific on certain types of sequences and series.